Hey guys, today we're going to be looking at how to solve one-step equations using algebra tiles. And so if you look right here, we have our key. So the long, skinny green rectangle represents x. The red, skinny rectangle represents a negative x. The yellow unit is a positive 1, and the red unit is a negative 1. Anytime that we solve an equation, our goal for solving the equation is to isolate the variable. That means that we want to get the variable all by itself. So the first equation that we're going to look at is x plus 2 is equal to 5. And so you see we already have x modeled with a positive green, x, 2 positive units, and it's equal to 5 negative units. And so in order to isolate x, we need to create 0 pairs. And so I'm going to add 2 negatives to both sides of the equation because I want to make sure that my equation stays balanced. So whatever I'm doing to one side of the equation, I want to do on the other. And now I notice that my positive yellow and my red, they create a 0 pair. So positive 1 and negative 1 makes that 0 pair. So I have 2 0 pairs I can cancel on the left, and I have 2 0 pairs I can cancel on the right. So when I take those away, all that I'm left with is that positive x is equal to a positive 3. So I know that x is equal to 3. Our next problem, we have x plus 3 negatives, which is equal to 8 negatives. So this has been modeled. And again, my goal for solving an equation is to isolate that variable. And so I want to create 0 pairs. I see that there are 3 negative units with my variable. So I will put 3 positive units on one side. And I will also need to do that to the other side because I want to keep that equation balanced. So now that I've created 0 pairs, I want to look to see if I can cancel any of them out. And I see that I have 3 0 pairs on the left and 3 0 pairs on the right. So I'm going to take those off of my board, which I'm going to show by erasing them. You can just simply pull them off your equation mat. And I am left with 1 whole x equal to 5 negatives. So this one looks a little different. So notice now we have a coefficient or a number in front of our variable. So we have 2 x's, which is equal to 6 positives. I don't have any 0 pairs I can make, but what I notice is that I have 6 positive units on that right-hand side, which I can share equally with the 2 x's. So I see that I can take 3 of these positives and say, hey, that will go with one of the positive x's. And I have 3 other positive yellows, or positive 3, and that can get shared with the other green. So what we've essentially done is we've taken those 6 positives and we've divided them into 2 groups so that we can see that 1 whole x is equal to 3 positives, which we can write mathematically by saying that 1x is equal to positive 3. Our last example that we're going to take a look at is similar to the previous problem. So notice that we have a coefficient of negative 3. So it says negative 3 x's, which is why we have 3 of the negative x's shown with our red algebra tiles. And that is equal to a positive 3. So similar to the last example, I notice that I can share those 3 positive yellows equally with each negative x, which I can then represent on my board by saying 1 negative x is equivalent to 1 positive 3. My goal is to find what 1 whole x, 1 whole positive x is, though. And so what I can do is I can flip my tiles over. So if I flip the red X tile over, now I see that it's green. But remember what we said about if we do one thing to one side of the equation, we want to do it to the other side as well. So since I flipped the negative x, I also want to flip the positive yellow unit. And when I do that, I see that one whole positive x is equal to a negative 1. All right, thank you.